What's up, y'all? Happy Wednesday, day 3. We're still on rigid transformations, but now we are looking at specifically thinking more about our things on a grid. Okay, that's our whole idea is thinking about our shapes on a grid, um, so we can kind of get better at thinking about what happens to our points and things like that. So let's transform some figures onto grids. That's, like I said, our goal. So take a second, pause the video. We have this different looking thing here. I don't know if you've ever seen it, but I want you to kind of think about, what are you noticing? What are you wondering? Why is this important? Okay, so pause the video and think about it. Um, Unfortunately, I'm not able to hear your responses, but I would always love to kind of hear about what you're thinking for this. The biggest thing I'm hoping that you take away from this is that not all of our grids that we look like are going to look like coordinate grids, whereas just your normal lines that you usually see, vertical and horizontal lines. Okay, this is called an isometric grid, and so this is very helpful for when we are doing transformations, because it does help us rotate in increments of 60 degrees. So if we're ever doing 60-degree increments of rotation, this is fantastic because each piece is 60 degrees of rotation. Whereas if we're looking at a normal coordinate grid that we're used to, we're doing 90-degree rotations. So an isometric grid is just very helpful. The likelihood of you seeing it in the future is slim, but I want to be very clear that all of our grids are not always going to be coordinate grids. We could see things like this, that are isometric, but know that we are still able to do transformations, translation, reflection, rotations on an isometric grid. Okay, so I'm going to take a second. Let's kind of look at this here, right? So we're now just kind of officially looking at how to do our transformations on our grid, on our coordinate grid. So if you have something like this, our goal is to try to get our A over to this, and then we know we have to match up this A to this A because they're both A's. So we need to match up those vertices. Anytime you see a little dash after your or your letters, that's your new image. That's where you're trying to get your old image to. We call this A prime. So we're trying to get our normal A on top of our A prime. That's our goal right now, okay? So what we're trying to do is we're trying to get this over to that next point, okay? So you can grab this and you can draw a line and you can connect it like this. And if you think about this, watch what happens. We went over, right? We went up 1, 2, over 1, 2, 3, 4, 5, 6, which means all of these need to do the exact same thing. They need to go up 1, 2 over 1, 2, 3, 4, 5, 6. So our C needs to go there, right? Up 1, 2 over 1, 2, 3, 4, 5, 6. That needs to be where our B goes. Okay. Hopefully this is making sense. Hopefully it works for you. All right. But that's kind of what we're thinking there, right? And now, if you think about this, oops, I don't want to do that. I don't want to do that. Okay, so now you can actually kind of look and see how this will move to our grid. Um, but yeah, so you can do it that way. You can also just hopefully have a ruler, y'all. If you don't have a ruler, find a straight edge or something, and you can actually just put your paper down and connect those points. Draw out those lines. You can actually visually see our translation there. Okay. This one here is the exact same thing, but now we're looking at line of reflection. Okay, so now we're doing a line of reflection, which is in fact a little bit different. So let's see here if we can get our line. So if we're trying to reflect over this line right now, okay, you need to make sure that you know, okay, so this is 1 unit away, which means it's going to be here when we reflect it. Okay, this is right on top of our line of reflection, so reflecting is on it. It's not going to go anywhere. Same with our B. Our C is the exact same way, right across from it, 1, and then count the other way, 1. It's going to be right there. Okay, that's how our reflections work. Okay, I'm hoping that you are kind of seeing like, oh, when you're reflecting, it's actually going one away on the other side. If it's 2 away on one side, it's going to be 2 away on the other side of that line of reflection. Um, Rotation is going to be a little bit more difficult, just because you really had to think about those degrees. So hopefully you have a projector, maybe. I hope, maybe. We'll see. Watch next video.